The try form in Plait lets us catch and handle exceptions, but indirectly it also provides the ability to jump from a nested expression to an enclosing context. For example, in this program we've intentionally applied 1 to 5 to trigger an expression that jumps out of the 2, 3, 4 addition and just returns 0 in place of the try. In other words, the try form records this continuation plus 1 dot and lets us jump there by triggering an exception. The letcc form lets us do this more directly. So here I've got letcc k1. The let part of letcc is because it binds the name k1, and the cc part is the current continuation. So the continuation of this letc form, that is plus 1 dot, that gets bound to k1. And then the program continues, but eventually it calls k1 on 5. So we've captured a continuation, but we're going to treat it like a function. We're going to apply it to the number 5, and that causes the continuation to be restored to plus 1 dot, and 5 dropped in as the result. So we continue and get 6 in this case. If we change the program to jump to k2 instead, k2 is the continuation at this point. And that continuation is adding 1, adding 2, adding 3 with a dot. I've left out the letcc around here for reasons that will become clear later. But this reflects the continuation of this letcc call here, and so when we jump to k2, that means we drop a 5 in place of the dot there, and we get, well, let's see, 11, right? I have this code set up in Dr. Rectit so we can try it out. If we run it as it is using k2, we do get 11. If we put k1 here, then we also get the 6, because that's 5 plus 1 is 6. I could ref this in another letcc and call it esc for escape, and I could escape all the way out and do none of the additions there. So this shows how letcc lets us give names to different continuations that we can jump to. And those are examples of jumping out of the current continuation, jumping out of a nested context to a continuation that was enclosing what we were doing already. But would it ever make sense to jump into a continuation? Here's an example that sets that up. So I've got plus 1, plus 2, plus 3, plus 4, and I've given a name escape to that outer continuation so I can escape. But I've also given a name to this inner continuation, k, which is the plus 1, plus 2, 3, 4. And I've taken that continuation and stored it in the continue function at the top level. Continue starts out as just being the identity function, but at this point I change continue to refer to that continuation. And then I escape with 0, which means return 0 to the continuation of this letcc, which just produces 0. The fun part is after that I call continue with 5, and that means I change the continuation of this expression to be the one that has plus 1, plus 2, plus 3, plus 4 after it. Let's try this out. So I've got that code ready here too. We see that what happens is we get the 0 printed out, just as we expect from this escape. And then when we continue with 5, we're dropping 5 into the plus 4, plus 2, plus 3, plus 1 continuation, and that's why we get 15 out. Continue is still here. It's a function, but also it prints out as a continuation because it's really a continuation kind of function. It has type number because we need to give it a number, and then it doesn't return anything in particular because it just prints that number out. I can call continue again on 0, and then we'll get a 10 out, or I could continue again with -1 and we get a 9 out, and so on. Every time I call continue, I restore that plus 1, plus 2, plus 3, plus 4 around the value that I give it, and it eventually adds up and prints out that result. So why would you ever want to jump into a continuation? Well, I'll show you some examples in a little while. This is one of those things where it's easier to look at the implementation before looking at examples of how it's used.